Welcome to Astronomy Daily, the podcast where we explore the latest in space and astronomy news. I'm your host, Anna. Today we have a fantastic lineup of stories that will take you from the high stakes of space travel to fascinating new scientific discoveries. From SpaceX facing challenges with their Falcon 9 rocket, to scientists measuring a planet-wide electric field for the first time ever, we have so much to explore. We'll also delve into Boom Supersonic's second test flight of their XB-1 aircraft, and wrap up with a look at the detection of water vapor in the atmosphere of an ultra-hot Saturn-like exoplanet. So grab your telescopes and let's dive in. First up today, the Federal Aviation Administration has grounded SpaceX's Falcon 9 rocket following a failed booster landing, marking the second mishap in less than 2 months. The booster in question, serial number B-1062, was consumed in a dramatic fireball on the deck of the drone ship, a Shortfall of Gravitas, stationed in the Atlantic Ocean. This incident occurred at the tail end of its record-setting 23rd flight, after having successfully launched a batch of Starlink satellites. In a statement, the FAA emphasized that while no injuries or public property damage were reported, an investigation has been mandated to thoroughly understand the root cause of the mishap. This grounding follows a similar stance taken by the FAA after a Falcon 9 upper stage failure on July 12th during the Starlink 9-3 mission, which led to the loss of 20 satellites. SpaceX rockets only resumed flights on July 27th for the Starlink 10-9 mission. Despite the setback, SpaceX remains steadfast in its commitment to resolving the issue. John Edwards, the SpaceX vice president of Falcon launch vehicles, highlighted on social media that, while unfortunate, the event posed no threat to the primary mission or public safety. He assured that the team is working diligently to identify the root cause and implement corrective actions as soon as possible. Similarly, Kiko Donchev, another high-ranking SpaceX official, stressed that the lessons learned from these recovery failures will not only enhance recovery reliability, but improve ascent reliability as well. This incident coincides with a challenging period for SpaceX, which had to delay the Polaris Dawn astronaut mission twice in the same week due to a helium leak and recovery weather concerns. The Polaris Dawn crew remains in quarantine, awaiting clearance for their next launch attempt. Timing for the Polaris Dawn launch remains uncertain, largely due to the ongoing FAA investigation, landing weather, and launch pad availability. The mission is set to take off from Launch Complex 39A at Kennedy Space Center, which also needs to be prepared for NASA's Europa Clipper mission with a launch window opening on October 10th. Complicating matters further, Space Launch Complex 40 at Cape Canaveral is already booked for NASA's Crew 9 mission to the International Space Station, penciled in for no earlier than September 24th. Ultimately, the date for Polaris Dawn will depend on how quickly SpaceX can satisfy the FAA's requirements and how cooperative the weather will be. It's a race against time for the SpaceX team, who continue to epitomize perseverance and adaptation in the relentless world of space exploration. Next, for the first time in history, scientists have successfully measured a planet-wide electric field known as the ambipolar electric field using NASA's Endurance mission. This breakthrough field plays a crucial role in atmospheric escape, shaping our ionosphere, and it opens new doors for understanding planetary atmospheres, not just on Earth, but also beyond. Let's dive into the discovery. The ambipolar electric field was first hypothesized over 6 decades ago. It was believed to drive how Earth's atmosphere escapes above the North and South poles. However, actually measuring it remained a challenge, until now. Utilizing data from NASA's Endurance mission, an international team of scientists has confirmed the existence of this field and even quantified its strength. The ambipolar electric field is subtle yet potent. Despite being weak, about 0.55 volts, roughly equivalent to a small watch battery, it draws particles from the atmosphere into space. This phenomenon has been termed the polar wind. For years, scientists noticed a stream of particles escaping from Earth's poles, but couldn't precisely explain why many were cool yet moving at supersonic speeds. Glyn Collinson, the principal investigator of the Endurance mission, noted that this minuscule electric field exerts a force 10 times stronger than gravity on hydrogen ions, which are the most abundant particles in the polar wind. To carry out their observations, the Endurance team chose an ideal location, Svalbard in the Norwegian Arctic, home to the northernmost rocket range. On May 11th, 2022, they launched their rocket, reaching an altitude of 477 miles. During its short-lived flight, the Endurance made groundbreaking measurements, unearth a mere 0.55 volts change in electric potential across 322 miles of altitude. Though minuscule, this measurement has vast implications. The significance of the results can't be overstated. This electric field can elevate particles, essentially acting as a conveyor belt, lifting the atmosphere into space. The research team found that the ambipolar field increases the ionosphere's scale height by 271%, allowing it to remain denser at higher altitudes. The implications extend far beyond Earth. Since the ambipolar field is generated by the internal dynamics of an atmosphere, it's expected to exist on other planets such as Venus and Mars. This discovery offers a new lens through which to explore the evolution of planetary atmospheres and even assess the habitability of other worlds. The study, published in the prestigious journal Nature, marks a significant milestone in our understanding of planetary atmospheres. With this knowledge, scientists can now begin to unravel the field's role and how it's been shaping our planet and potentially others over time. That's a wrap on this fascinating breakthrough in atmospheric science. Stick around as we delve into more groundbreaking discoveries here on Astronomy Daily. Boom Supersonic's XB-1 aircraft successfully completed its second test flight from the Mojave Air and Spaceport. This flight, lasting about 15 minutes, saw the XB-1 reaching an altitude of 10,400 feet and achieving a speed of 277 miles per hour. Impressively, this flight demonstrated the retraction and extension of landing gear for the first time, along with testing a new digital stability augmentation system designed to enhance handling. Blake Scholl, founder and CEO of Boom Supersonic, shared his excitement by saying, "XB-1 had a fantastic second flight this morning. Initial results indicate we've successfully resolved the findings from Flight 1 and are excited to continue flight testing on the path to supersonic flight." This milestone marks another significant step towards the return of supersonic passenger travel, a goal that Boom Supersonic is inching closer to with each successful test. The XB-1 test plane had its maiden flight earlier in March of this year. Now, Boom Supersonic is looking to ramp up its flight rate with around 10 more tests planned before attempting supersonic speeds. Each test brings the company closer to achieving its ambitious objectives of revolutionizing air travel, making it faster and more efficient. The XB-1 program is part of the broader design and development process for Boom's flagship project, Overture, a planned supersonic airliner. Boom Supersonic envisions a future where supersonic travel redefines the pace of global air travel, cutting down travel times significantly. This recent test flight underscores their commitment to bringing that vision to life, one flight at a time. As the team at Boom Supersonic continues to push the bounds of aviation technology, the promise of supersonic passenger travel edges closer to becoming a reality, holding the potential to transform the way we think about air travel in the not-so-distant future. Next up, yet another exciting discovery involving water. Researchers have detected water vapor in the atmosphere of HD 149026b, an ultra-hot Saturn-like exoplanet located approximately 250 light-years away in the constellation of Hercules. This exoplanet, which is similar in size to Saturn, has an extremely close orbit to its host star, nearly 10 times closer than Mercury's orbit around the Sun. As a result, it completes a full orbit in just about 2.9 days, leading to surface temperatures soaring above 1700 Kelvin, hot enough to melt even the strongest steel. The discovery of water vapor was made using a technique called transmission spectroscopy. This method involves observing the planet as it transits, or passes in front of its host star from our perspective on Earth. When this happens, some of the star's light filters through the planet's atmosphere. The gases in the atmosphere absorb specific wavelengths of light, creating a unique absorption spectrum, which can be detected and analyzed. One of the major challenges in observing the atmosphere of such exoplanets lies in the high contrast between the bright star and the dim planet. This high contrast often means that the planetary atmospheric signatures are exceedingly faint and can be easily lost in the stellar photon noise. However, the extreme temperatures and close proximity of HD 149026b to its host star made the atmospheric detection somewhat easier, albeit still a significant challenge. The strength of these atmospheric signatures would be stronger for hotter planets, as their atmospheres are more extended and therefore more detectable. Despite the inherent difficulties, the researchers were able to separate the planetary absorption spectrum from the stellar spectrum by analyzing the light before and during the transit. This allowed them to identify and confirm the presence of water vapor in the planet's atmosphere. This discovery provides valuable insights into the characteristics and composition of exoplanetary atmospheres, shedding light on the complex processes occurring in these distant worlds. Research like this not only deepens our understanding of exoplanets, but also helps us piece together the vast diversity of planetary systems beyond our own. Thank you for tuning into Astronomy Daily. I'm your host, Anna. For more exciting content, be sure to visit our website at astronomydaily.io. There, you can catch up on the latest space and astronomy news with our constantly updating newsfeed. You can also sign up for our free daily newsletter so you never miss a beat in the cosmos. If you enjoyed today's episode, don't forget to check out our archive of past episodes for more fascinating stories and insights. We're also active on social media, sharing the latest updates and engaging with our community. Find us on Facebook, X, YouTube, and TikTok by searching for Astro Daily Pod. Your support helps us bring you the best in space news and discoveries, so join us and be part of our journey to the stars. Until next time, keep looking up.